everyone. So today we're going to be doing lesson 4 of trig identities. So this is going to be focusing on difference of squares with factoring and also conjugating. So before we start doing the examples, I just want to recall one of the equations we are going to be working with throughout this unit. It's going to be cos squared theta is equal to 1 minus sine squared theta. So for conjugating, this is where you have normally two perfect squared numbers and we're breaking it down into a plus minus version of it. So what I mean by this is when you were in grade 11, you might have seen x squared minus 1, and then you would break this up into x plus 1, x minus 1, right? That's a difference of squares. So this is kind of like the same concept, but now we're going to be focusing with trig functions. So in trig, whenever you see a 1 minus sine theta, for example like this, or you might see a 4 minus, but typically it's usually just 1. That means you're going to usually be working with conjugation or difference of squares. So from our 1 minus sine squared theta at the top here, if you were to break this down even further, because since we have 1, this is the same thing as 1 squared. If you were to break up both of these squares into difference of squares, it's going to become 1 minus sine theta and 1 plus sine theta. Again, similar to the x squared minus 1 you've seen before. So now we're going to get started on some examples. So here, I'm just going to rewrite our charts. Cosecant squared x minus 1 is all over cosecant squared x. And then we have cos squared x. So one thing I want to note is sometimes some students see that both the numerator and denominator here both have cosecant squared x. You can't cancel these out because the cosecant squared x has a minus 1 attached to it, so you can't actually cancel them. So I'm going to change the left-hand side. So before you jump into changing into sines and cos, what you should look for first is, can I change anything? And normally, it's usually a formula. It's going to be on your formula sheet that you could change. So here, if you look at cosecant squared x, this is actually the formula 1 plus cotangent squared x. And this, again, can be seen on your formula sheet. So we're going to replace only the cosecant squared x in the numerator with that. We're not going to do the same thing in the denominator. You'll see why in a bit. But we're only going to change the one part first. So here, this is 1 plus cotangent squared x. And then we're bringing back the minus 1 from earlier, all over cosecant squared x. And then we see the 1's cancel. So now we're left with cotangent squared x over cosecant squared x. And now at this stage, it looks a lot more easier to work around with it. So now we're going to change it into sine and cos. So a lot of this unit is basically just trying out different methods and hoping things work out. You'll just learn how to adapt the tricks as you go on. So here, cotangent is the same thing as cos squared x over sine squared x. And be careful with x's and thetas. Do not get them mixed up. And cosecant is just 1 over sine squared x, or cosecant squared x, sorry. And then now, from here, it's going to become cosecant squared x over sine squared x times sine squared x over 1. Sine squared x cancels, and now we're left with cosecant squared x. And now, the left-hand side equals right-hand side. So again, just to recall, cotangent squared x is the same thing as, not sine, sorry, cos squared x over sine squared x. If this was a cube, it would be cos cube x over sine cube x, and so on. So that pattern applies. Now we're on letter B. So for letter B, here we see we have secant theta plus tan theta equals cos theta over 1 minus sine theta. So now this method is going to be talking about conjugation. For me, how I know when I should conjugate is if the side I'm working, well, hold on, let me rewrite it first. Or let me think this out. If the side I'm working with, so I'm going to start with the left side first. If this side doesn't have a 1 minus trig function or a trig function minus 1, but my right side does, so in this case here, we see that we have that pattern. That means I'm going to do some conjugation to cancel things out in order to get that part. So again, if the side I'm starting with doesn't have either of these brackets, that means I'm going to do some conjugation if the other side, so my right side, does have it. I hope that makes sense. So I'm going to change my left side first into cos and sine. So this is 1 over cos theta plus sine theta over cos theta. And then now I'm going to combine everything into one fraction because we see they're all have a denominator of cos already. So now you have 1 plus sine theta all over cos theta. And then now I want my end goal to have the 1 minus sine theta, and I already have the 1 plus sine theta. That means I'm going to conjugate. So here I'm going to multiply this by 1 minus sine theta. Do not forget your brackets. And make sure to write this for both the numerator and the denominator, because this red term here is actually going to simplify to becoming just 1 over 1, right? So now, with my difference of square rules, my numerator is going to turn to 1 minus sine squared theta, and this becomes cos theta over 1 minus sine theta. And then now, what can I change? So here, if you look at your numerator, 1 minus sine squared theta, this is going to become cos squared theta. So cos squared theta all over cos theta times 1 minus sine theta. So one thing I forgot to mention, when you're at this stage here, do not FOIL it quite yet. Check if your next step will allow you to cancel anything out. And it can. So here, the cos theta cancels, and only a single cos theta at the top cancels. So now, we're left with cos theta all over 1 minus sine theta. And now left-hand side equals right-hand side. That's just my tip on how I know when I'm going to conjugate. Again, you could go about this in different methods. You could even start with the right side first if you wanted, but that's just how I like to go about these questions. You don't have to do it that way. So now we're on to the last lesson. Oh, you could see some of my leftover writing here because I was like practicing how to tackle this. So here, tan theta minus sine theta all over sine theta bracket sine squared theta. I actually recorded this video earlier, but I decided to restart it because I realized I wrote a little too big and I ran out of room. So that's why there was leftover writing. So for this question here, you're not going to FOIL your sine theta and sine squared theta, because if you have sine cubed theta, that's not really anything on your formula sheet. So what we're first going to do instead is we are going to change everything on the left side into terms of sine and cos. So here, tan theta, that's going to be sine theta over cos theta minus sine theta over 1. I just like putting the over 1 because when I do my fraction rules later, it's just easier for me to see how everything plays out. And then this is all over sine theta times sine squared theta. And now I'm going to have the same denominators for the stuff in the bracket. So here I'm going to multiply this by cos theta. And this is multiplied by 1. You don't have to write that, but I'm just showing you guys how it would work. So now this is going to become sine theta minus sine theta cos theta. And since they all have the same denominator now, it's going to become all over just a single cos theta. And now I'm going to rewrite my denominator, sine theta, sine squared theta. So at this stage, we're going to see what can we change, what can we do. So for the top part here in the bracket, we see that both terms at the top has a sine theta. So that means you could factor out sine theta. So that's what I'm going to do. So sine theta bracket 1 minus cos theta is going to be all over cos theta. And now that whole part here is all going to be over sine theta. And I want to change to sine squared theta now. So if you look at your formula sheet or the last example, we see and know sine squared theta is the same thing as 1 minus cos squared theta. So at this stage, some alarm should be going off in your head where you're like, oh, I have a 1 minus cos squared theta. That means I could probably do difference of squares. And look at that. At our numerator here, there's a 1 minus cos theta, so some things are probably going to be canceling out soon. So I'm just going to do my fraction rules so you can see that. So here, that whole part here is realistically over 1. So now I'm just going to rewrite it so you can see everything cancel. Over cos theta times 1 minus sine theta. And then, just to recall, 1 minus cos squared theta is the same thing as 1 minus cos theta times 1 minus, or 1 plus cos theta. So this is the difference of squares rule. So I'm just going to write that out. 1 minus cos theta, 1 plus cos theta. And then things will cancel. So here, sine thetas cancel, the 1 minus cos theta cancels, and then nothing else cancels. So here, I'm left with 1 over cos theta times 1 plus cos theta. And this is where a lot of students tend to get stuck, where they're like, oh, what can I change to make it the left-hand side equal the right-hand side? So the right-hand side, we have secant theta over 1 plus cos theta. And if you recall, secant theta is the same thing as 1 over cos. So we actually have that here. We just need to break it up so you could see it. So this is the same thing as 1 over cos theta times 1 over 1 plus cos theta. So we're just separating these fractions so you could see it play out. And then now, this is the same thing as secant theta times 1 over 1 plus cos theta. And then now, that's going to be left with, I'm just going to write here, secant theta all over 1 plus cos theta. And now we have left-hand side equals right-hand side. And that's it for today's lesson. So your homework is going to be these trigonometric identities. Please do at least half of them. And again, a good indicator for if you're going to be conjugating or not is if you see 1 minus or 1 plus a trig function. That's a good tell. But that's it for today's lesson. So if you need any help with anything, please feel free to reach out. But that's it for today. Bye!